Good morning, everyone. Today I'm going to present how fuzzy theory is applied to evaluating the performance of the activated sludge process. This study combines mathematical logic and wastewater treatment, making it an interesting intersection of applied science and engineering. Before we begin, let's briefly look at the table of contents. First, I'm gonna introduce the basic concept of fuzzy inference and calculation. And then I'll show you the main process of fuzzy inference and the way it is applied to the activated sludge process. So, first of all, let's look at the fuzzy inference. Unlike traditional yes or no logic, fuzzy logic allows for degrees of truth, enabling a more nuanced analysis of complex systems. This is particularly useful when dealing with uncertain or imprecise data, and the converting process of exact value to this uncertain fuzzy value is defined as fuzzy inference. For example, if we consider a simple whole set U equals 1 and 2 and 3, we can represent it as a fuzzy set with membership values, which is M1 equals 20%, M2 equals 30%, and M3 equals 70%. These values indicate the degree to which each element belongs to the fuzzy set, offering a more flexible way to model real-world problems. So, the function means that number 1 is 20% partially included in the fuzzy set. And it's very simple to calculate the fuzzy set. Fuzzy set operations resemble traditional set operations, but introduce membership function that assign partial truth values, and it's a little bit different. Union of two or more membership function comes out as the maximum value between the initial values. Like I said before, M1 equals 20% and M2 equals 30%. If those two functions go through the union process, we can get the output of 30%. Intersection comes out as minimum value between the initial values, which is 20%. Other operations are similar with traditional set operations. This principle forms the foundation for fuzzy inference systems, which we'll now explore in more details. Main process. There are two main types of fuzzy inference systems, Mamdani type and Scannell type. Both way have four main steps in the process and really small difference. Mamdani type. This method involves four steps: fuzzification, rule evaluation, aggregation, and defuzzification. It uses rules in form of if A input, then B output. So the fuzzification is the first step. Let's think about the example. If you look at the next slide picture and consider an input of study time and an output representing the probability of grade improvement. If the rule states if study time is high and the probability of grade improvement is high, we can assign fuzzy membership values to different study times in direct proportional ratio. We can use this rule. First, we need to put in exact number, study time which equals 5 hours, and based on the poll, we can check out the degree of inclusion. 5 hours has 50% inclusion in the low study time and 75% inclusion in the average study time and 0% in the high sector. You can write this conclusion as 0.5, 0.75, and 0. Next step, we gotta do the rule evaluation. So we got the inclusion of 0.5, 0.75, and 0. And rules set in the beginning should be applied to this inclusion by using the fuzzy set calculation. Since the rule is really simple, the study time and the possibility of grade improvement is directly proportional. Even after applying rules, inclusion of the possibility of grade improvement, small, average, high, comes out as same as 0.5, 0.75, and 0. You can see this in this picture too. Next, aggregation and defalsification. The result 0.7, 0.5, 0.75, and 0 can be visualized, and the painted part can be aggregated like this graph. And lastly, the centroid technique enables defalsification process. We can derive the conclusion that 5 hours of study a day makes 31% possibility of grade improvement from the fuzzy inference. Next, we have the scanner type. Scanner type uses this method employs mathematical functions rather than the qualitative categories, eliminating the need for defalsification. Because it is computationally simpler, it is often preferred for real-time control systems. Next, I'm going to introduce activated sludge process. The activated sludge process is a biological method that uses microorganisms to treat wastewater. Several factors influence its efficiency. There are 5 factors, and those 5 factors are effluent quality, which is EQ, sludge production, which is SP, pumping energy, PE, aeration energy, AE, and mixing energy, ME. To briefly introduce about the factors, EQ equals as water quality, SP equals as how much sludge has been gone into the process, and AE equals injected amount of oxygen to boost the effect of sludge, and air and mixing energy and aeration energy and pumping energy. So to evaluate different sludge treatment process, we analyzed 3 methods: A2 oxygen and VIP and DNR process. Initial findings were the A2 oxygen performed best in terms of effluent quality, VIP was the most efficient in the sludge production and aeration energy, and DNR excelled in pumping and mixing energy. However, the best process cannot be determined by simply comparing individual performance indicators. Instead, a fuzzy inference system was applied to assign importance weights to key indicators. The results of defalsification show that A2 oxygen scored 0.509, which was good. VIP process as 0.486, which was good, also good, and DNR process, which was 0.281, which was excellent. So thus the DNR process was determined to be the most effective overall. In the next slide, and table 8, table 9, and the picture in the right, you can see the process of the fuzzy inference, falsification, and defalsification, rule evaluation, and aggregation of the shape like I did before, and the centroid technique. In conclusion, fuzzy inference provides a valuable tool for evaluating complex processes such as wastewater treatment. By allowing flexible decision making, it helps optimize system performance beyond simple numerical comparisons. Thank you for listening.